Let's solve x squared plus 6x equals 10. Okay, 6 is a linear coefficient, right? It's the number in front of x. So don't include, for linear coefficient, it's not 6x, it's just 6. So the x tells you where to look, right? It's just the 6. And then the half of that is the second stick. So 3 is the second stick. And by second stick, I'm saying that's the casual version of the length of the second stick, right? But in that picture, right, there's that second stick, its length is 3. And so if we square the number 3, it's 9 that we need to add to both sides. So here's some pictures just to make sure. The first picture is x squared plus 6x, right? Because it's x squared plus 3x plus 3x. The second picture is the completed square. It's x squared plus 3x plus 3x plus 9, or in other words, x squared plus 6x plus 9. So, right, what's missing, because the second stick is we've discovered is a 3, that was half the linear coefficient, right? Because 3x plus 3x is the 6x. What's missing in the lower right corner is this 9, so we needed 9. But we can't just add 9 to the left side. We got to add 9 to the right side as well. So take the original equation up there. Sorry for all that discussion in blue along with all these pictures. But if we add 9 to both sides, we'll have x squared plus 6x plus 9 equals 10 plus 9. Factor the left side, x plus 3 quantity squared. Right side is some arithmetic. 10 plus 9 simplifies to 19. Now, square root both sides. You can skip writing this step if you want, but please note that the first step you write that has square roots in it, the first step in which you square root both sides, has to have a plus or minus sign. So you might skip the step in gray and just directly go to x plus 3 equals plus or minus root 19. But the first step in which there's any evidence of square rooting on both sides needs to have a plus or minus sign. Now, subtract 3 on both sides. So x equals negative 3 plus or minus root 19. Let's do one more. Let's solve x squared plus 22x equals negative 20. All right, linear coefficient, 22. Yeah, the number in front of x. Let's then say half that should be the second stick, right? 11 is the second stick. And then the constant that we need to add is whatever the square of 11 is. So 11 squared, or 11 times 11. I believe that's 121. So we need to add that to both sides. Before doing that, actually, let's just draw the pictures again, just to help clarify that the original left side of x squared plus 22x can also be thought of as x squared plus 11x plus 11x. And that's not a perfect square. It's missing this little corner. It's like it's chipped off here, right? So how do we fill this in? It's got to be 11 times 11, or in other words, 121 here. This second picture is that completed square. It's x squared plus 22x plus 121. So we add 121 to both sides, right? So just to make sure, the original equation's left side is x squared plus 22x. That's the picture here with the 3 yellow panels. The first line of the answer, the left side is x squared plus 22x plus 121. That's the picture. That left side, the picture is what you see, the picture that has the 4 yellow panels, x squared plus 11x plus 11x plus 121. On the right side, there was a minus 20, and remember we added 121 to both sides, so I just stuck the positive 121 in front, so it's 121 minus 20. You could very well have written negative 20 plus 121 if you want. Now let's factor the left side and simplify the right side. So x plus 11 quantity squared equals 101. Notice how this factored, right? It was x plus the second stick. Second stick was 11. X plus second stick quantity squared equals 101. Now square root both sides. Yeah, so root x plus 11 squared equals plus or minus root 101. And then the left side simplifies because the square root and the square undo each other. We have x plus 11 is equal to plus or minus root 101. Subtract 11 on both sides. So x is equal to negative 11 plus or minus root 101. If we took the previous question's equation, so you look at x squared plus 22x equals negative 20. That was the equation we just solved. If you tried yesterday's method, yesterday's method was about the zero product property, right? What you do is we try to get a 0 on one side. So we'd add 20 to both sides. We'd have x squared plus 22x plus 20 equals 0. Good, there's a 0 on one side. And then the zero product property strategy says you've got to then factor the left side. But we would actually struggle to factor x squared plus 22x plus 20 because we'd be trying to think of two numbers that multiply to 20. And when you add the two numbers, you get 22 and we'd scratch our heads and go, how does that work? So that's it's, that zero product property based strategy, it just doesn't always work out. So let's say this, there's a comparison of strategies that now fits into one bigger strategy. Given a quadratic equation, if one side is 0 and factoring the other side If it's easy to do or you notice it, then the zero product property. But here's the thing. If one side is 0 and factoring the other side looks difficult or impossible, like the example we were just looking at, then, yeah, here's the thing. If you don't have factors, in other words, you don't have a product on one side and then a 0 on the other, you just can't use the zero product property. So when that doesn't work out, instead complete the square. And so what you need to do is you have got to add the same number to both sides, right? It's always valid to add the same number to both sides, even if the number doesn't appear in the original problem. But what number should you add to both sides? Well, you take the linear coefficient and the number in front of x, like we took earlier, take the number 22, and then divide by 2, and that's the length of the second stick. So in the example we were looking at, that was 11, right? But it's not the number 11 to add to both sides. Instead, you take that second stick, which in our last example was 11, you square that number, just kind of off to the side, in our case 121, and 121. That is the number to add to both sides. So I know it seems strange, but in the last question, we took x squared plus 22x equals negative 20, and we added the number 121 to both sides, even though there was no 121 that was visible in the original equation. Why? Because it worked out, because it completed the square. So please note that this strategy, right, you use this whenever the zero product property doesn't apply if you have a quadratic equation.